All right, we're talking about mechanical advantage. Mechanical advantage is just telling you how much is your simple tool making the work easier, not making the work less. The simple machine does not actually do work for you. In the case of a lever, it's a rigid board. That's all it is a piece of wood. A piece of wood can't do work for you. But the way that you use that rigid board around a lever can make the work easier because you only have to apply you can apply a less force in order to get your object to move. But remember this, what you gain in effort, you pay for in distance. So I have to apply that less effort over a greater distance to get the object to move as much as it would move without my simple machine. So I have to apply the less force over a greater distance. And remember that work is force times distance. So what I gain, what I don't have to pay in my effort, I now do have to pay in distance so that it all ends up being the same. And you saw that with the illustration of the inclined plane that I gave you on Power School. So again, a simple machine helps you either to gain effort so that you don't have to put as much effort in to move the resistance, but what I gain in effort I pay for in distance. Or if it's a third class lever or something like that, instead I'm going to be gaining in distance and I would have to pay for it in my effort. It's going to require more effort to move it less distance. I don't have to move it that far, but I do have to put in a lot of effort in order to get it to move that little bit of distance. All right, let's talk about a couple of these and what this looks like. Here is your T for mechanical advantage if I'm talking about a lever or actually anything at all. This is the specific T for an inclined plane, but this will work for every simple machine. So what is the mechanical advantage of a lever if it takes 400 pounds to lift 120 pounds? So it's taking me 40 pounds. That's the effort I have to put into it, so that's why I labeled it E. And the load that I'm trying to lift is 120 pounds. And so when I put it into this T, then my mechanical advantage is 3. Notice that there's not a unit for mechanical advantage. It's just a comparison of load and effort, so it doesn't have its own unit. Now on the flip side of that, let's say that I know I have a simple machine that has a mechanical advantage of 3. How much effort would it take then for me to lift a 900-pound load? So I put my load on the top. I know now my simple machine mechanical advantage, and so I can find the effort. It would only take me 300 pounds. On the flip side of it, I'm going to have to move it 3 times farther to get it to the original distance it would be without the tool. So let's say that if I were just lifting it up and I only had to lift it up 1 foot. Well, now I'm going to, and that would make 1 foot times 900 or 900 foot-pounds. Don't worry about the unit for that. Well, if I need to do the work of 900 foot-pounds, then 300 times what would give me my 900 foot-pounds? It would be 3 feet. So let me say that again. My total work is 900 foot-pounds. So I could lift, without my simple machine, I could lift my 900 pounds, the 1 foot that it needs to go up, and that would be my 900 foot-pounds. But now, with my simple machine, it only requires me to lift or to push with 300 pounds, but I'm going to have to push that over a distance of 3 feet rather than 1 foot. So what I gain in effort, I pay for in distance, so that my force times my distance is the same with or without the simple machine. All right, now the next one is how much effort is needed to raise 400 pounds with a single movable pulley. I know that a single movable pulley has a mechanical advantage of 2. All single movable pulleys have a mechanical advantage of 2. A single fixed pulley has a mechanical advantage of 1. So if my load is 400 pounds, How much effort do I need? Mechanical advantage is 2 because it is a single movable pulley. My load, or what I'm trying to lift, is 400 pounds. And so that's why they go here. And I'm trying to find out, well, if I've got my pulley, how much effort do I have to put in? I only have to put in 200 pounds. So I'm lifting with a force of 200 pounds in order to raise a 400-pound weight. But remember, what I gain in effort, I pay for in distance. So whatever distance that my 400 pounds has to go up, let's say that I want it to go up 10 feet. Let's say I'm raising something to a loft in a barn. So from the floor of the barn to the loft is 10 feet. And if I have a single movable pulley, I actually would have to go through 20 feet of rope in order to lift it up, because what I gain in effort, I pay for in distance. If I half my effort, I have to double my distance. All right, and then this last one, what is the mechanical advantage of a third-class lever that requires 400 newtons in order to raise 100 newtons? Now, in this case, that sounds really backwards. Now I'm putting in 400 newtons of effort just to raise 100 newtons of load. This is going to be then 100 over 400. So sometimes you actually do have a decimal for an answer for this. And in this case, it's going to be 0.25. So you have a less than 1. But the more effort I have, what I'm gaining in effort, what I'm losing in effort, I'm gaining in distance. I don't have to move it as far to get the same bang for my buck. So it's just the opposite. If this is less than 1, then I'm taking advantage of my simple machine to not have to move it as far. But for greater than 1, I'm taking advantage of my simple machine to not have to need as much effort. All right, and let me just show you quickly again what it would look like. And I just wanted to do one like this so that you can see the T. Let's say that I have a load here, and I'm going to say that this is 8 feet, and this then is going to be 4 feet high. And I am going to move let's say that I want to move a 300-pound weight. Okay, so let's talk about what this actually means. So let's find the mechanical advantage of my inclined plane. So mechanical advantage is slant length, which is 8. And then my mechanical advantage is here, and my height is 4. So this gives me, remember, if it's over each other, you divide. So it gives me a mechanical advantage of 2. And again, I'm just using the T that I had at the very top. Slant length, mechanical advantage, height. The slant length of my inclined plane was 8, so the 8 goes on the top. And the height of my inclined plane is 4, so that goes on the bottom. I have a mechanical advantage of 2. So now let's see how much effort it's going to take me. I know that my mechanical advantage is 2. I just found that out. I have a 300-pound load, so they're over each other, and I'm going to divide. So my effort is going to be 150 pounds. Now I love an inclined plane because that really illustrates the effort versus the distance principle here. It only takes me 150 pounds to push on this. I will be able to move 300 pounds with 150 pounds of effort. That's super easy. But I have to do it over 8 feet. So if I just clean lifted this from here to here, it would take me 300 pounds, but I would only have to lift it over 4 feet. Here, I only need 150 pounds, but I have to double the distance. Half of my effort, but double the distance. But it's way easier to push this up the 8 feet than it is to just clean lift it up the 4 feet. I can do this all day. This would be difficult, and so that's why we use simple machines. But again, I want you to see that that if I had the box here instead and I had to lift it up, I'd only have to lift it up 4 feet to put it wherever it is that I want it to go up here at the top. 4 feet, that's all I'd have to lift it. But here, and I would have to use 300 pounds to lift it the 4 feet. But here I only need 150 pounds because my mechanical advantage is 2. I only need 150 pounds to push it, but now I'm pushing it over twice the length. So what I gain in effort, I pay for in distance. Still a good deal as far as I'm concerned because it makes the effort less. All right, there are going to be some problems for you to try. So go ahead and give those a shot. And if you have any questions, certainly reach out to me and let me know.